Alrighty, thank you guys for being here. I'm Michael Shepard, and I was lucky enough to go to MDRS and perform some research after a few months of preparing, and its applications of remote surveillance in Mars analog, which will make a little bit more sense here in just a moment. The basic idea is I wanted to create some form of surveillance where I could observe the environment around me while I was safe inside. In fact, you spoke earlier about the suits and the hazards of a closed system, and all of the risks that go along with getting strapped up, depressurizing, going outside and hoping nothing goes wrong. And so I kind of try to see what I can do to circumvent that with maybe some everyday tasks, or whatever we find out down the road. Again, kind of reiterating what I just said, I guess, we don't do so well on Mars. So anything that we can do to avoid going outside, will hopefully give us a little longevity. No mistakes or anything like that. And technology improves our ability to do that. Just a little bit about Mars analog. I know the group over here all kind of knows these things, but maybe you'll learn something new. So it simulates the environment as closely as is possible on Earth, and in practice you go to Painter Desert in Utah, and it's extremely convincing, to say the least. You're way away from anything. We drove about 2.5 hours to middle of nowhere to get there, and it's pretty crazy out there. It's a freezing cold part of the year and burning hot the rest. So yeah, my goals while I was there were to have a live feed where I could see in real time what my surveillance was doing. It wasn't retroactive or anything like that. It's more than just recording data and looking back. It's doing things in real time, accomplishing goals, and also being able to kind of control that, not just looking at a camera pointed at, some telemetry where you're looking at water levels or anything like that, but being able to manipulate where you're at in your environment and actually see what's going on. A big part of this is radio signals. You want to avoid, getting anything confused. Any interference is either going to cause your video to go out on your flying device, or it's going to cause a disruption in your flight, which is obviously pretty bad. Comes crashing down, and you no longer have the ability to do this anymore. And lastly, it has to perform some practical tasks. You can't just be a cool toy that you take to Mars and get to play around with when you're not doing anything else. You will be busy, I'm sure, and this would hopefully be a tool that improves your experience and your ability to get things done. The original plan was kind of complicated. You'd have yourself, you would have a transmitter and a monitor that you were viewing things from, and you'd have a cord running to an antenna sitting on the building, but that would transmit to your surveillance device, and it would signal its information back in real time to your antenna, which would then come back to you. So a little bit of a setup, but nothing that wouldn't be manageable, with just running a wire and an antenna up. Kind of playing around with those ideas and building some prototypes, seeing what works. I kind of learned that you really don't need to go to all that trouble. Commercially available radio frequency devices are much more powerful than is necessary to accomplish this without running wires all over the place. So this actually ended up being very convenient. It became not only a device that was easy to set up, but that you could move the entire operation at will. It ended up being very useful. And a big part of this was the fact that we could use 250 milliwatts. I think what's the maximum legal ability is an entire watt, I believe. So you could get 4 times stronger than what I used, which is pretty impressive. It just kind of goes to show you don't have to have a complicated setup just because technology is so advanced that it keeps it really simple with just one transmitter and one receiver. The antennas were another thing that took it a long way. This specific type of antenna was very useful in transmitting data and not having weak spots. You didn't have to point it in the right direction or anything like that. It has a certain amount of integrity that it can gain or lose by its direction, but even at its worst, it's still more than capable of going about a mile away at the 250 megawatts, which is very nice. And then the controller, a lower frequency meant it has longer range and less fidelity. So you can't send complicated, like, high definition video over this frequency as well, but it will go very far without losing its integrity. And so this is what I end up coming up with. You have yourself inside on the left with a controller, a monitor, and your transmitter and receiver. And you're transmitting your ability to control your device through one frequency at 2.4 gigahertz. And your video signal at 5.8 gigahertz. 5.8 is kind of your typical Wi-Fi signal, so you have an idea of what you can do with that. You know, you can view high definition video in real time and things like that. Anything you can do on the internet, you can do with like a 5.8 gigahertz signal. It has enough power to do so. And outside is going to be a quadcopter with a camera connected to a transmitter and a receiver that again records in live and real time, and also can record for retroactive just viewing. This was the receiver. It was very mobile. Again, like I said, you've got batteries and you've got wires, but really you can just, the whole bottom part you can just kind of collapse and it all stays together, and then you've got something that's, you know, maybe 2 feet tall that you can carry around, you can put in a backpack. And this actually came in handy for our EVAs. Once I established that I was able to sit inside of the hab and fly about 1.5 miles around before losing signal and perform tasks, I was able to read telemetry, I was able to fly around, I was able to see the water levels outside in the tank well enough. And so once I established that my basic goal was really kind of simple once I got there, which was really neat because it allowed me to kind of push what my system was able to do. So with this being so mobile, I was able to take it around with me, which I'll show you here in a quick little video in a minute. So I'll get through this and we'll look at that. But yeah, so this guy was really portable, very small monitor that doesn't lose fidelity. A lot of TVs will just turn off if the signal gets weak. This was just specifically designed to just display whatever. So if it's a black screen, it's a black screen. If it's a small amount of static, it'll show static. But it is also possible of showing up to high definition video, which is very, very useful to see what was going on around me. The quadcopter, again, 2.4 gigahertz, long range, medium strength signal. In and of itself, I went with a pretty standard quadcopter. Anybody that's familiar with them will have heard of them. It's just there are packages that will come with like your GPS and your compass that you can calibrate to do what you need. Relatively simple, so I was able to kind of suit it to my needs. Again, the monitor, pretty simple, really portable. My video capabilities were that I had real-time sight. You can very easily implement an on-screen display, which is something I plan on doing in the future. Gives you all kinds of information, how far away you are, you know, in real time, how far away you are, how fast you're moving, how high you are, those kinds of things. Again, high definition video that was stored on the camera itself while I was flying, so that later on, this is actually a still from that, from in flight going about 30 miles an hour, and just high definition pictures and video. Very useful for going back, seeing what you did, recording data if you need to do that. Some resources, and can I switch over to the video and show a little bit of that really quick?
Sure.
Yeah. So again, I was easily able to achieve the ability to sit inside and kind of watch what was going on, but that got boring. So I took it with me outside and went on EVAs. And one of the EVAs was the chemistry one in Candor Chasma. And I was able to take off. And during this EVA, I don't know how universal the EVAs are, if they were our own. We were able to, the point of this EVA was to go down into the canyon and look for a certain type of sediment that you can kind of see sitting in the riverbank. So I was able to fly up high enough and scope out where it was. So in that first shot, I'm actually going to go back to that. You can easily see from fairly far away where this white sediment is in the riverbed. So we'll go up pretty much as soon as we lift off. You can see out and over where the sediment is, and it's actually pretty cool because it really helped out. And it was also just cool to fly a quadcopter through a canyon, and, you know, kind of a bird's eye view. So yeah, so as you can see, this is what we were looking for along here, and it was really easy to find, and it came in handy, and it was very neat. And I'll show you one more area, kind of gives you an idea of the scope that you're able to see. So here we are flying around, and as you can see, there's the tracks for the four-wheelers, and those little dots right next to it, those are people. And so we're standing at the edge of what you look down in, and it's just kind of this massive expanse before you. And this was really kind of the neatest thing that I was able to do, is just kind of see the whole big picture of where we were at in Mars analog, and kind of take everything in at once. So yeah, I guess that's about it. And I guess I'll leave it to questions. Oh, just the video. I can keep the video running and things like that. I know there are two spots that are really good for kind of showing what it does.
Did you have any problems with interference between the frequencies, video and?
My first prototype ran 2.4 gigahertz on both. So you would turn it on and your video would get a little fuzzy, and you'd fly up and your video would go out, and it was terrifying. And so we didn't fly more than about 20 feet like that. You can do line of sight, like a normal quadcopter is designed to kind of, you just watch it fly around from your perspective, but the video going out, kind of once you're comfortable with it, feels like it's the way you should do it. So yeah, my first prototype, absolute interference. So I switched up frequencies.
The camera was built into the
No, I bought a GoPro camera separately, and that's where a lot of my research came in. I didn't know anything about quadcopters or cameras, but making them work together using, like, there are Chinese standards of cords that plug into the quadcopter and American standards for cords and power, like voltages that go into the camera itself. And so I just kind of did some modification on the cords and to make it go together. And so I just kind of put this.
The transmission, you use the one in the quadcopter, right? Or you take another board to do that?
You can change the transmission frequency. Mm-hmm. They come in both, but you can do modifications to change it. Yes?
Can you talk about the value of this kind of technology with respect to the simulation experience?
Again, like the main goal, I guess, coming back to the start, was that it really allows you to do a whole lot. It allows you to. Sorry. When I got distracted by my video, I was watching it there and turned around and saw it again. So, without having to go outside, again, she spoke of the pressurization suits. Aside from like avoiding any like potential harm and things like that, you kind of have an intermediary view, because we have satellites that are kind of going over, and we see the big picture. Like we're looking down and we have like topographical maps and everything like that. But having kind of an intermediary view of everything around you. Again, we had the people the person that was here earlier about geology, and scoping out the area around them. So they were getting on four-wheelers and they were scoping out spots, but we're really only able to go about 1.5 miles away. Well, that's the range that I can fly at 40 miles an hour and still be in contact. So you kind of can get to a point, you have a radius that you can search, and then you can, move, and there's all sorts of applications that allow you to be safe and or get a better perspective on your surroundings. So.
And I just want to make sure I know what you're saying is that one of the features of what you did was that being able to record and watch the video live was a unique.
Right, independently. The GoPro camera itself is designed to just be a camera that records. You can go out and record a video, and then you can watch it later. But the point of my project was that you are able to have a live feed of exactly what's going on and have the video recording at the same time so that you can look back and see if what your preliminary findings were true or more accurate later on. Yeah. Yeah. Yes, sir.
I think these type of rotary drones aren't going to work on Mars because of the atmospheric pressure.
Right.
Are you looking at other potential vehicles for the camera?
Absolutely. There's a reason we've sent multiple rovers to Mars and that they are on wheels. Obviously, propellers, I think it was like 50,000 times faster is the equivalent, your proportion, to be on Mars. That's not going to happen, right? I understand that a propeller system will not be the one that gives you mobility. There are all sorts of little things that you see here and there. There are kinds that kind of do this like fluttering effect that allows it to kind of free fall and continuously push itself up, that they've proven that works in low atmosphere situations. And I guess that's just going to come from, the point of this was applications of surveillance, right? I was very careful because I do understand that the research for mobility is going to come from trial and error and seeing what works in that kind of environment. So, thank you. Josh.
Did you have anything besides visual flight to keep reference of the attitude, the situation, the awareness of the actual aircraft? So there's bars and stuff on the screen.
Right. So that was a sample of an on-screen display that you can pick up and kind of add into some of these systems. I mean, really that just comes down to throwing more money at it. Like all you do is you buy the chip and you plug it in between your transmitter and your camera, and it just does it for you. And so while if I had all the money in the world, I obviously would have had it. It wasn't necessary. I have a GPS tracking system. I'm capable of understanding how far away I am. You have landmarks to reference and things like that. Maybe a little old-fashioned, but like I said, without just throwing more money at it and getting it, you're still able to kind of understand these things. So, yeah. Alrighty. Well, if that's it for questions, I want to thank you guys for being here.
For a real quick question on the GoPro or other cameras, there between live and what's actually recorded, there is a time delay. About how long did you notice any, and about how long?
Well, the
time delay between live and.
Well, so I mean the camera, it's transmitting at frequency, like just radio frequency, and so there was not any humanly distinguishable lag between, because you're not a considerable distance away. So what I'm seeing on the live feed is where the quadricopter is actually at, and it's the high definition video is actually stored on the camera itself. So I fly it back, I take the memory card out. I don't have it recording through the TV because the video quality would suffer, because a live feed is obviously not going to be as good. But the camera itself records in high definition. I bring it back to me. I'm able to take the memory card out and put it on a computer. Yeah. Yeah. All right. Well, thank you guys.